it's better because then if you have a couple of days in between, then you need to just revise everything. So luckily it's one day compact. Okay, so regarding this worksheet, as you see here, it's a mixture of two topics actually. One regarding the functions and in particular the operation that we introduced today, the composition function. And the other is some calculations with vectors. Actually, some of them we didn't do with vectors. So up to maybe Roman 5, we can do it, or 4. So the first two parts of assignment 3, we already know how to do it, up to the unit vector, number 5. So up to here. Now let me see the students. So guys online, we are going to have a look at the worksheet number 2. As I mentioned, the topics we covered up to this part here, maybe zoom it out a little bit. Okay, up to here, Okay, two first questions related to functions, just to make sure that there are copies.
Yeah, do you want one? Oh,
Do I need to print more? Okay, so the first two questions, just to make sure that you understand the concept of a function and to be able to determine the domain and range of a function, and the composite function is something that we introduced today. And as I said, the first 5 parts of the question number 3. Just leave it, maybe some more will come. Leave it somewhere. Thank you. Okay, guys online. Wir können Yes, I will. So someone is asking about uploading the solutions. I will definitely. But it's good attitude. So again, I don't know whether the students online can hear me. Please just write something. Yes, okay, you can hear me. So regarding the classes, you know, we have two sections. One today, which is meant to be hybrid, and tomorrow we have the same class from 8 to 1 p.m. Now I'm going to use the first slot tomorrow for online and, so to speak, hybrid. So there will be here also the tutorial. So because of that, we will start with the tutorial tomorrow. If you don't attend now this session, then you can attend tomorrow morning, 8 o'clock. I see I need to print more. So no one is coming tomorrow, maybe. I'm sure that the neighbors are complaining now because of the noise. Are there copies for everyone here, or shall I print more? You need more?
Yes.
There's one.
So I see tomorrow the class will be empty. What time do you wake up usually? Afternoon? Maybe I should ask what time you go to bed. This is, you know, in I think 29th, they're going to switch to the winter time in Germany. Is this better? We will have 1 hour more sleep or? So we'll have winter time in 2 weeks, right? Okay, so you can try the worksheet and tell me if you need specific help, so I will get more copies. If you don't attend this session, it will be repeated tomorrow morning, 8 o'clock until 9:30. Okay? And on site, both on site and online. So let me get the copies from the printer.
Already? It's like, what is it? Find this out.
When are you doing this one? The second one? Second one is very straightforward. Yeah, the first one is kind of unclear. It's a basically.
So here, what copies? Maybe interesting in the second question is to try to evaluate G composite F at 2. So this is optional. G composite F at 2. The guy who asked the question related to this is not here, but maybe he will be tomorrow morning there.
So, my sister.
So please, guys and back, you can work in small groups, but be quiet. So you can work in small groups, 2, 3 people, if someone can explain better to the other, but without disturbing the others, please. System launch profile video both. But there we have another lecture tomorrow.
Yeah. Oh, but I wouldn't know. It's like.
Regarding last week's tutorial, anyone Googled infinity in which of the sets is it? Infinity? Did anyone try to find out infinity? No?
Yeah. Okay, let's take whatever. Yeah. So it's X, Y. Plus Y. What are two? Okay. Yeah. So circle. We'll have a circle forward. So this is not it. Yeah. But there's like a hot. Oh, okay, so we know here is the top.
Yeah.
Oh, no.
Yeah, I'm trying to follow the same process.
Yeah. So in practice, when you make it on first.
Right, so. So basically.
Because I have it's almost most so this for this thing you get 13.
That's what I got.
Yes.
Right.
The first one. Think about it. What is this? So, okay, let's solve number one together. Let's see here. This is a half circle, right? Guys in the back, if you just pay attention a little bit. Question number one. Half a circle, is it a function? So this is a circle with upper half, right? So in upper half, let me just put it here. So you have here two ways actually to solve it. So this is here R, this is R, this point is R, and this is negative R, right? So this magnitude is R. I think it's clear what is. It's a function. Yes, it is a function. Because obviously we don't have the easiest thing is to argue this is the vertical line test. It will not touch more than one point at the same time. Okay, so this is definitely a function, but be careful. Circles are not functions, but the upper half is a function. Now, what is the domain and range? Now think about it. What are the domain? So domain here to remind you x values. Okay, or sorry? No, R is a constant, as R is a real number. You can think about R, I don't know, if you have a circle 16 minus R squared, or X squared, sorry. R is a real number under the square root, okay? You can think about what are values that will make this. Not only. So here you have the value. This is the domain. Obviously, this is the x values, right? You can't see it. So domain is, if you like, negative R and R as interval. You see it? From negative R to R. Maybe if you just like an example. So it means here it's half circle with a radius R. Okay. So if you go here to the left, then you will be having values. If you square it, it will give you a negative value under the square root, right?
That's only complex numbers.
So you and the range here obviously from 0 to R. The range is 0 to R. Okay. Now number two. Is it clear, or shall I just not clear? Okay, again, I have here just to remind you, what does it mean? What does it mean here? What does it mean that the domain of function? What does it mean? It means the allowed, or the input values that make sense, right? The x values that make sense. And now when talking about real numbers, what makes sense actually is that the amount under the root is not zero, not negative, sorry. So that means here, if you like, y equals the square root of r squared minus x squared. Okay? Now, obviously, if you take any value beyond r, either to the left or to the right, and square it, this amount will become negative. Let's take concrete example. Maybe here you are confused because of the constant r. So if this is here, let's take this example. This is -4, and this is +4. This is +4 because it's a circle. Okay. Now here is 16. Now any value here, let's take 5. Okay, you take 5, you square it, you subtract 16 from 25. You will be getting negative, right? So it's not a real number. The same here if you take -5 to the left. So values that make sense here are, in this case, is the interval -4 and 4. This domain here. Okay. Now how to do it, to do it this analytically? I will give you a very algebraic, let's say, method. Now you remember we said that the problem is we had two cases where we can get problem, and two major cases, let me say, where we can get problems in real numbers. If I have a denominator that is 0, or I have an amount under the square root that is negative, and I need to rule out these from the domain. This is not allowed in real numbers, these both cases. So in this case here, what is the problem here? Y equals, let's say, square root of 16 minus x squared. This 16 minus x squared is greater or equal to 0. Okay? If you solve this inequality, you are done, actually. You solve this inequality because this is or these are the values of x that make sense. Now, how to solve these? We want to know what values make this equal to 0, okay? So 16 minus x squared equals to 0. So x equals 4 and x equals -4, right? So far. Now from this point, these 4 and -4, we call them in mathematics critical points. What does it mean, critical points? That means at these points, to the right and to the left, something is changing. Something is changing. Here is the sign of the product. So let's assume this is 4, this is -4. Okay? And we want values that makes this positive. We want values that makes this positive. Here we have, you notice we have here 1, 2, 3, let's say, subpoints. The domain is split in three portions. This part, the part in the middle, and this part. And it's enough. This actually, let's say this method we will use very often throughout this course and beyond, to take test points. Now, why is this valid for the whole interval. This is something that's still premature, but think about this. We can do it. This is because of continuity. So here you take this point, let's say, as we took before, -5. Here you take +5, for instance, and here in the middle you take 0. Okay? Now let's start with this part here. -5. So 16 minus -5 squared is 25 minus plus 6, so you have 9, right? Negative. Square root of -9 is not defined, so I exclude this range. The interval from -infinity to -5. Okay? Everyone agrees? Yes. Does that make sense? The guys in the back are not with us. Okay? So let's see. Students online.
No, but
Where can here is not correct. Okay. Now we take the area in the middle. So this one here, this area here, this interval here, it doesn't fit because it will cause a problem. Actually, this whole area. Now this one here in the middle, just plug in 0, so it will work. You will be having positive. Let's take another value, 1 for instance. Then you have 16 minus 1 square root of 15. So this one is okay. Here to the right, it will not work. So the interval here is obviously -4 and 4. So this is the answer for the domain. Okay?
And what about
If it's R, it's -R and R. Okay? Notice that here it's the square root of 16 because R squared here is 4 squared. Yes.
But then what about the range?
Yeah, the range here is another story. The range here is what? The range is values of the range y is equal to 0, right? No, x is equal to 0. The range are values along the y-axis, which is basically here clear from this graph. Yeah? Notice that here the values of y, think about here along the y-axis, okay? They start at 0 and they just increase until you get here to the radius, either r or in this specific example 4. So it can't fall below. So here, notice that I'm thinking now along the y-axis. So this is the decisive factor for the domain, for the range. Sorry. Here in the negative, it will not fall down here into the negative. Okay. So the possible y values are here 0, then here up there, which are positive. Then it will not go beyond r or beyond 4. Okay. So if
0 and 4,
and 4, exactly.
or R in this case.
Exactly. So the range is here 0 and 4, or in general 0 and r. Domain here -r and okay. So again, to just to wrap it up and remind you, if you are trying to find the domain or range of function, usually we have these classical cases or two, let's say, examples or two critical cases where you have to pay extra care to. One, like in this example, this amount under the square root, it can't be negative. So you exclude all values that will make this negative. Clear?
Yes.
To be able to do that logically, you need to know where is this 0, because from the right and the left of 0 you have negative and positive. Okay, you need to have a reference point. The reference points here are the points that make this equal to 0. That's why we evaluated them. Okay, then do the analysis using these critical points. As you see here, you can take test points within each interval, and whatever applies for the test point will apply for the whole interval. Another critical case is when the denominator is 0, not equal, not positive, not negative, exactly 0. This you need to exclude. We will see in the next example. Okay. So is it clear now? Question number 1. Okay, let's move to question number 2. Question. I tend to use the computation terminology in this because it is it's something that we face in our daily life. Okay, so I would say that the allowed input, it's just like if you are filling an application form on the internet, then they will tell you, okay, this should be, I don't know, 5 digits, or the only numbers are valid, or date, or whatever. So if the allowed form of input is the domain, the allowed form is of output is the range. Okay, question number 2. Today we studied this, and let me see. So question number 2 says the following. So I have two functions, f of x, which is it s cube minus 2x over x. It's minus 2 or 2 minus x.
It's +2, yes. +2.
Plus. Okay, thank you. And g of x is equal to x. Okay. Now we said that the composition function f composite g of x, we just had it today, this morning. We evaluated inside out. Okay, so it's f of, let me just put it in these brackets. What does that mean? That means here, instead of evaluating f of x here, you need to replace it by g of x. So here, wherever you have x, you just replace it with the g of x. Okay, and if you like here, it's f of, if we plug in here g of x, which is 2x. Now let's evaluate it. Then we have 2x cubed, right? Plus 2 times 2x. So wherever you have x, you just plug in g of x. 2x minus 2. Let me just close this. Okay, so here there is some. Now I see sometimes some students, they are not able to evaluate this. What is this according to the so it's 2 to the power 3 times x to the power 3, right? So it's 8x to the power 3 plus 4x over 2x minus 2. I don't know whether there's, you can take 2 as a common factor, but that's all. So the thing here is, whatever you have here in the original function, wherever you have x, you plug in the value of g of x. That's all. Yes. Sorry. You solved it. Yeah, you can. So let me just repeat this thing here. Now. So just look at this one. Here we are plugging in 2x wherever we have x, right? Here in the original formula we have x cubed. So it's not 2x cubed, it's 2x all cubed. You got it? Now here we can of course take 2 as a common factor. So here you can simplify it. You can say it's 2 times 4x cubed plus 2x over what I got here, x minus 1. Okay. Now the second one is G composite F. And this is equal to G of F of X. Let me just use the square brackets here. Okay. That means here in this case, I will be plugging in the formula of F of X in G. Okay. Correct? What did you get? By 2. Exactly. So here this is 2 times x cubed plus x 2x over x minus 2. Is it the same? No. Okay. So very simple. You just break down this composite function using the definition, starting inside out. Plug in the value of x in the original formula wherever you have x. That's it. If there is simplification, you can simplify. Yes, please.
How do we calculate the magnitude for each vector?
You square all terms and take the square root.
Okay.
Okay.
Mhm.
So yeah, for instance, for the first one, 0 squared plus 2 squared plus minus 2 squared, all under the square.
Okay, so everything must be positive or
Yes, of course. You square it, it can't be negative.
okay, thank you.
Okay, so now this part here, part 2, and I added part 3 also. Anyway, part 2 it says evaluate F composite G of 3. So here F from this is part 1. From 1 we have this F composite G of x equals to 8x cubed plus 4x over 2x minus 2. So F composite G of 3 equals to 8. I'm not going to calculate it. So 3 to the power 3 plus 4 times 3. So wherever I have x, Okay, so you just plug into. So here you need, no need to evaluate it again. You have it up there. I use this formula.
Sign, use this symbol or a true
Yes.
line?
Okay. Just plug in 3 in the first formula. Okay, it's just now the thing I added here, G composite F of 2. Now imagine now what I do need to do, I need to plug in 2 or to evaluate F of 2, but F of 2 is not defined because this will cause the denominator to be 0. Okay, so I hope this is clear that this is not defined. This is not defined because here it will cause this to be 0 and it's not defined. Okay, I see that maybe question number 4 here is still number 4 here. We didn't introduce the multiplication yet, so just try to solve the first 2, 3 maybe. It's straight substitution in the formulas.
Well, this is the back of the cave. These are story. Yeah, no, it's magnitude. Yeah, what am I seeing? Yeah, it is.
Here. Yeah.
Add that all together and do the other back corner of that.
Right.
Sorry. Yeah, you can do the same thing, but they're all.
Okay, what did we do here? So we take here the 2. But if you expand this directly, it will give you this amount, right? Then it will expand here and expand here, here, and here. But if you have only one x here, where you get the 2? You got it? So if you are saying here that there is no 2 here, right? It's 1. Okay, then just do it the other way around. Just expand the 2 inside here. You will not get the same formula like before.
Yeah.
Come on, guys. This is basic mathematics. If you want to divide factor, fraction, you divide it factor by factor, right? Let's do it. Let's do it step by step here, okay? So your colleagues are saying here we can take 4 here as a common factor, and then take 2 down and then cancel them out. It's not the same. Okay, let me just show you how this works. Okay, 8x cubed plus 4x over 2x minus 2. So far agree, yeah? Okay, let's divide everything by 2. Okay, let's do it the school mathematics. So it will be 8 over 2 times x cubed plus 4 over 2 times x divided by 2x over 2 minus 2 over 2. So this is actually how we divide fractions of polynomials. Sorry? Yeah, but you know what? Your colleagues are arguing that you can take 4 here as a common factor and 2 here as a common factor, then cancel them out, then here you will end up having 1 as coefficient. This is not possible.
I don't get it.
You got it? You can't divide the denominator by a number and the denominator by another number because it's 1. So if you divide everything by 2, obviously here you will be ending up of having 1, 1. And 2 as the common factor because we divided by 2. Now if you expand your terms there, the way you do it will
So they're asking 3. Ah, yeah, that's
Okay, so what your colleague was doing is correct too, because he just this one here, he just had 2 as a common factor of the denominator. So if you write it 2 times 4x cubed plus 1, no, plus 2 x, and this one here x minus 1. It's the same, isn't it? It's just the same.
The day is true that the forbidden value in this case would be 1.
Which one?
And this function, the forbidden value will be 1. Would it? For x.
You mean here this formula?
Yeah.
No, this is a variable. Now here, if you want to, yeah, if you want to talk about domain, yeah, then it's r minus 1. Okay, so I'm not going to some techniques that we will need to define, but I will just give you some. Okay, now please just pay attention. I will give you some hints and some, let's say, formulas that you will need to do question number 3. We studied today in general about vectors, but let me just make it specific here to 3-dimensional vectors. Now in literature, when we talk about vectors and 3-dimensional vectors, in some literature, they are just given as a row with 3 values. Okay, for instance, you can have 2.
I don't think it's that one, though.
Sorry.
It is not product, but I think
Or you can write it 0 to -2. It's just the same. Vectors are defined in linear algebra either as a row or a column.
here, and this one here.
So as long as you interpret this as x value, y value, z value, x value, y value, z value, it doesn't make a big difference. Okay. Now things like let's see an example. Things like 3/2 or 3/2. If this is a, 3/2 times a.
Yeah.
Okay, you just multiply term by term. So 0 times 3/2, 2 times 3/2, and -2 times 3/2. So this will give you 0, 3, -3, right?
Yeah.
Okay, because here the constant here, it's expanded term by term. Okay, you can of course write it this way. So the thing here is this constant 3/2 will be expanded to all coordinates of the vector. Okay, and the same applies if you are multiplying with any other number. Now the other thing is the unit vector. Now if you have a vector in general, let's say a, b, c, if this is a vector in R3, then the magnitude of this vector is simply defined as the square root. Actually, it's for n times n, a squared plus b squared plus c squared. Here you have to be careful. If you have negative, then you square it. It becomes, if you square it, it becomes positive. I see some students, they just, if you have -2 squared, they write -4. No, it's -2 all squared, it will give you +4. So as it's defined here, it's never negative. Yeah, it's never negative.
Have to change it.
Okay. Now a unit vector unit vector of V is simply equal 1 over the magnitude of V times the vector itself. Okay, I just multiply by the reciprocal because in this case I will be getting rid of the, it's just like multiplying 5 by 1 over 5 to get 1. So here we multiply by the reciprocal of the magnitude. Okay, things like when lines are parallel or orthogonal, which means perpendicular to each other, these we will need some more, let's say, theory behind that, like the multiplication, dot product, and cross product of vectors. That what we will be doing next week. Okay. So any questions regarding that?
Yes,
Yes, please.
I have more. In what case will you even calculate the unit vector exactly?
In what case?
Because why would you calculate the unit vector? What do we need it for exactly?
Yeah, it's actually the unit vector in mathematics is simplifies things because the behavior there, it's usually in physics, it's not about the magnitude, it's rather about the behavior, and there is decisive is the angle. And then if you make unit vector out of that, then the calculations will be easier. Then you can expand it. So whatever will apply to a vector, I don't know, 1,000 units will be the same for 1 unit. So it's just for simplification. So mathematics, very often they are using one. I don't know whether you studied trigonometric, they use the so-called unit circle, for instance. They can use any other circle, but one is nice, easy to calculate and substitute. And then you can just expand it at the end. Yes, yes. Okay, now when evaluating, okay, so now I will tell you a very nice thing about these vectors that we will need. Now we said that any vector in 3D, it can be represented in form of the so-called unit vectors. So I told you that these unit vectors, then we call them E1, or it can be called also E sub X in some literature, E sub A2, E sub Y, or so this is also now for 3D, this is of course 1 0 0, this is 0 1 0, and this one is 0 0 1. Now in 3D algebra, they introduce, especially in English textbooks and in English literature, they use this one, the unit vector in X direction, they just call it I, sometimes with the hat on top of it. This one, they call it J. This one is, we call it just K, which is the same, In the XYZ plane, this is, let me just try to plot it here. Okay, if this is X, this is Y. I hope you still can see it. This is Z. This vector here, the unit vector in direction X is I. This direction is, no, sorry, this is J. This is I. And this is Z. Sorry, K. Now here, so let's agree from now, whenever we have a vector, three-dimensional vector, the first component is multiplied by I, which is the unit vector in the X direction. The second component is multiplied by the unit vector in the J direction, and this one is the unit vector in K direction. This we will need for next class to simplify, in particular, cross product. I see that many students, they have different methods. We have here a mixture of, I don't know how many countries, 30 countries maybe, and in some countries they just have other methods of evaluating things. In this particular this particular definition of three-dimensional vectors will simplify the cross product in particular. Okay? If you are used to any other method, no problem. So here, for instance, I see very often that even in some literature, they just use X bold with the hat on top of it, Y, and so on. As long as this is interpreted as that, they have no problem, but it will be better if you just get used to this notation, I, J, and K. Anyone has problem with that? Okay. Any questions regarding the worksheet? I saw here there were some disputes.
How do we calculate the unit vector again?
You
Did you have to follow?
multiply by the reciprocal of the, you evaluated already? Yes, we evaluated in the previous step the magnitude, right? Then you divide all terms here by the magnitude.
Divide all terms by the magnitude.
Yeah.
Oh, okay.
Or multiply by the reciprocal of the magnitude.
Right, thank you.
Okay? Yes, please.
So the next from A on to B, right? It's gonna be dot product from A that B over negative.
Yes, B multiplied by the vector. Depends whether you only want to dimension. The vector. I will get to them first. Because we didn't include the Let's so for instance A. Okay, please guys be seated a little bit. I will just I have a question here by a colleague of your colleague here. We have let's evaluate the unit vector A equals 0, 2, minus 2.
Magnitude is 0, 2, 2.
Unit vector of A. Okay, fine. Okay. Now here, according to the definition, the unit vector of A equals 1 over the magnitude of A multiplied by A, right? Now, what is the magnitude of A?
Magnitude 0, 2.
0 squared plus 2 squared plus minus 2 squared, all under the square root. This is what I was warning from, okay? So here is the square root of 8, right? You got it?
Yes.
So here, be careful. If you have a negative here, you need to square it. You need to square all. It's not minus 2 squared is not minus 4. It's minus 2 all squared, so it's positive 4. Okay? Then from there, it's very easy. Then E equals to Okay, so 1 over square root of 8 multiplied by 0 to negative 2. So this is 0, 2 over square root of 8, negative 2 over square root of 8. Okay, so you just put them here in row. Okay, multiply by 1. So this will work always because the only case you have 0 is divided by 0 is for the 0 vector. But the 0 vector has no unit vector. You can't make a vector out of 1. Nothing, right? Okay. So before we end, I just asked you last time, what about the infinity, number infinity? Which of the sets we introduced does it belong to?
If you have any questions.
So since you are all connected to online, I want you to try to find out to which of these is infinity a natural number? Is it an integer? Is it a rational? Is it an irrational? Is it a real number? Just find out and let me know in what you're Infinity. Sorry, you Google it already? Infinity, is it a natural number, an integer, a rational, an irrational? All of them. Sorry? All of them. Just Google it. It's interesting. It's very interesting. Yeah, infinity is actually it's you know they have a nice term in German. This is less halter, that's halter. You know, that's halter. I don't know what's the term in English. Is it less keeping or something like that? It's something that is not it's not a specific value. Last time I told you about two terms in mathematics: undefined and indeterminate. Undefined, indeterminate. Undefined is dividing by 0. It's undefined, and one of these is infinity. You will see later when we talk about sequences. If you have the reciprocal of 0, that means you have a very no. If you have a reciprocal of infinity, you are approaching 0. Okay, you have 1 divided by the largest number without knowing what is this number, then we say it's close to 0 because we know that the numerator is inverse proportional to the number, right? So you have 1 over 5 and 1 over 50. Which one is larger? 1 over 5 or 1 over 50 is larger? As the denominator gets larger, then you are approaching a very small number. Actually. Now, infinity is something in mathematics, it's philosophy. Yeah? So please Google, just ask Google, is infinity a real number? Is it a rational number? Maybe a rational number is good. Is it a rational number? This sure.
Most likely.
Rational number. Then how will you write it as a fraction? Infinity over 1? Obviously. Or is there any repeating button if you write it? Can you write it as a decimal? So no one get to some conclusion? Okay, I give you a couple of minutes to discuss it. I don't know whether you will be getting a definite answer.
No.
What is no? Ah,
I love it like that.
so Leopard, what did you find out?
Mine is like so. Is that the graphic one? That's that one, like,
So,
on my teacher.
are you looking for infinity or?
It's not a number. Question.
It's not a number. Of course, it's not a number. But this is what I'm saying. It's place keeper, right? It's not. It's a number, but it's not. It's a number, but it's not. It doesn't have a definite value, right?
Right.
But it belongs. Yeah, we just you see. We were just drawing the real number line. It could be infinity here. So it must belong somewhere, no? If it's real number, then it must be in some of the sets that construct the ultimately the real number.
Yeah.
So is it rational?
And then.
It says no.
It says no, it's not rational. Then ask, is it irrational? So, actually, you know, in logic, you have this what we call tautology. So everything is either it is or not something, right? Okay. So is it irrational?
It is irrational.
Yeah.
Well, I can't see the logic. Honestly, I can't see the logic. But the thing is, you can't write it as a fraction, and it's in R. So you have any reasonable?
Well, for infinity, it's not a definite
Yeah.
number.
Yeah, it's like an infinite, like,
Right?
series
Yeah.
of going up or going down.
Yeah.
Like pi continues.
Yeah, but the decisive thing is that it's not the number, it's the decimal, you know, digits.
Right, but after only 1/4, it just keeps.
Yeah. So, and you can't write it as a fraction. This is something you can't write it as fraction.
Right.
And if you consider it a natural number, then infinity plus basically you got it. So it can't be natural, it can't be integer,
It's irrational.
it can't be it's irrational. So I hope that you will make up your mind that it's irrational and hence a real number. But it's not. Yes, please.
Can you check the first word?
You want?
I want the projection, but it's like this. It's the temporal of the-
I mean, which one is that?
the projection of the-
No, but it seems as I don't want to say place it, but I don't know if that's right.
Yes, yes. There's one have. I need to check the formula is correct. So you have to be careful. Then you have to divide what you are doing here is okay, so keep it, then compare it with the answer.
And the-
Sorry. Okay, so see you. Please, when you go out, please, when you go out, just be a little bit, right? Because the other class. All right. Goodbye.
Goodbye, sir.